Hello, my name is Alex. I'm from Hong Kong, and for my CS50 final project, I made a genetic algorithm sandbox game. This program was written in Python. It consists of two sections. The game, which is based off of World's Hardest Game. It's a fun game on coolmaths.com. And then I also made a genetic algorithm to try to beat that game. So when you open the program, you can try to make your own level. It's a game. So what you start off with is a small square. This is what represents the player. You also have the starting and end points. The start point is where the player spawns on, and then the end point is where the player wants to get to. The player can move with his arrow keys, left, right, up, and down. Then you have obstacles that act as obstacles, so when you hit it, you can't go through them. You also have enemies that move between fixed positions. When you hit the enemy, you get teleported back to your spawn point, so you don't want to hit them. Then you have, then I made the genetic algorithm. So genetic algorithms, they simulate natural selection. And what you do is, you first start with a population. In my case, it was 1,000 of those squares. This time they were organized, controlled by the computer, not by me. And then they contained genes, which were basically just move orders. So left here, and then right, and then up, and then down. And that's basically what it contained. And so what I did was, I let them go for, let's say, 20 seconds. And then I see which one was the closest to the endpoint. And based off of that, they were assigned a fitness value, which represents how good that member did in that generation. And then the higher the fitness value, the higher the probability that they would be able to provide offspring for the next generation. And then I mutated the offspring just to add some diversity. That would pretty much shape up the new generation. But that's only one of many generations. You would loop through each generation over and over again, going through the same cycle, just trying to find the optimal solution in that given time. I've also included a short time lapse of the process in action. I started off by using some lines as obstacles in order to create a simple level that the computer would try to beat. And then afterwards, the genetic algorithm just did its own thing, starting with 1,000 squares and moved slowly towards the right. At first it was random, but at the end, it was smart. And yeah, this is just the final solution it found.